chapters, and now we're going to back up and come into unit rates. The reason why we're going to go into unit rates is because we had to know all these other things about fractions before we could get into this. In your book, I want you to put a box around the word ratio and rate before I even get going on it. It says, a ratio that compares two quantities with different kinds of units is called a rate. So the rate is a ratio that's comparing the two. When you found each other's pulse, you were actually finding heart rate. Okay? So for example, if I had 160 beats in 2 minutes, the units beats and minutes are different. So because the label on the top, which is beats, and the label on the bottom is minutes, because these labels are different, we now call it a rate. Okay, and it's because it was a ratio of two items, but it became the word rate because they don't have the same, you're not measuring the same type of thing. Okay? Just like when we've been doing on our bell work. We've been doing like miles per hour, right? Yeah. Cost per pound. So when a rate is simplified so that the denominator of 1, it is called a unit rate. Over here, you're going to write unit. Whenever we say unit, unit equals the number 1. You always need to know that unit means 1. Okay? So what it's saying is you're reducing 160 and 2 by 2 to get 80 over 1. Because it's over 1, it became my unit rate. Sometimes it's not as easy to reduce these. So to also become a unit or a unit rate, all I am doing is taking this numerator divided by the denominator. So over here, I want you to show 160 divided by 2. We're going to keep our labels. It's 160 beats divided by 2 minutes is 80 beats per minute. Whatever's on top, beats is on top, minutes are on the bottom, so beats will be listed first, minutes will be listed second. So just to find the unit rate, you're just dividing numerator divided by denominator. Common examples in this chart below, we've kind of already discussed some of these for our bell work. If we have the number of miles over the number of hours, that's called miles per hour. That's when we talk about how fast we're driving. You can abbreviate it MI/H. I usually make an hour HR. Either way is fine, or MPH. Then I just leave it MPH. And that's considered your average speed. Number of miles per gallon. That's when you're driving a car, how many miles per gallon can you get on a gallon of gas? So you write miles per gallon, MI/GAL or MPG, and that's your gas mileage. You guys that like big trucks, your trucks don't get good gas mileage. Your miles per gallon is going to be very, very small. Or people who drive like a little economy cars, their miles per gallon is going to be a bigger number. If you're trying to be cost efficient, you probably want to go with a smaller vehicle because then it's not going to cost as much to drive. Number of dollars per pound. It's called price per pound. Dollars per pound, the unit price. Unit price. Circle that. Because the unit can be anything. Cost is always going to be on the top. So I want, for an example, you're going to write dollars per item. Because it's cost per item. Like there's 12 bags there's 12 apples in a bag. The bag costs $2.99. How much is it per apple? My apple would be on the bottom. Anytime I see this line or hear the word per, it's $1 per item. Add the PER. So I might have cost per pound, cost per apple, cost per ounce, cost per hour, cost per what? Box. Whatever it may be, cost dollar amount will always be on top. Okay? You guys got to remember, when I'm ever setting these up, dollars is on top. So let's look at our first example. Adrian biked 24 miles in 4 hours. If she biked at a constant speed, how many miles did she ride in 1 hour? They give us our example. They have 24 miles in 4 hours, but this is not how I'm going to want to see it. How I'm going to want to see it is I'll write it onto this space right here. First and foremost, just like in the bell work, I want you to start with labels. Do not attach any numbers with the labels. I have to look at, so I read it once. I'm going to go back in and read it twice. Adrian biked 24 miles in 4 hours. If she biked at a constant speed, so that'd be kind of like a constant rate, how many miles did she ride in 1 hour? So what's my label going to be? Miles per hour. So then over here I'm going to write miles, or MI, over hours. That is the first thing that you'll do. You'll start with the label with nothing with it. Then I'm going to come in and now I'm going to attach my numbers that are in my problem. Do I know how many miles I biked?
Yes.
How many?
24.
So I'm going to write 24 miles over, I know how long that took her. 4 hours. Now if you look here at their example, they're showing us that we're reducing it to get the denominator to equal 1, so I'm reducing it by 4. Sometimes it's not that easy. So instead of reducing it by 4, I'm going to do what do you think is my easy way that I'm going to show you? Divide the problem. It's a fraction. It's a fractions division. So I'm going to show it. Show that I'm going to here. 24 divided by 4. I know you can do that in your head, but I need you to show me that that's what you're doing because it's not going to be that easy. So 24 divided by 4 is 6. Then I'm going to rewrite. It's 6 miles per hour. Okay? I want to see it in this format more than that format. I want to see that you're starting with your labels, then you're filling in your numbers that you found with your labels, and then you're doing the division. Okay? Let's go on and try another example. So to find each unit rate, round to the nearest hundredth if needed, or if necessary. That's important. We're going to round to the nearest hundredth. Now, we have $300 for 6 hours. What's my label that, I'm going to only start with labels. I know it gives me numbers with it, but what label goes on top? Anybody?
Dollars.
So I'm going to show dollars over
Hour.
Did I put any numbers with it?
No.
No. Now my second one, I'm going to put in $300 for 6 hours. If you know how to reduce it down, like what can I divide both of them by to get one on the bottom, you can do that. But let's say I don't. What was my next step to do? What am I going to divide?
The top by 300.
The numerator divided by the denominator. So 300 divided by 6. 6 doesn't go into 3, but it goes into the 30 5 times, which is exact, so it would be 50. Then I'm going to rewrite it as 50.
Miles per. No.
No.
$50
So I got to have my dollar sign. $50
per hour.
per hour. And I'm going to use that slash.
Sounds pretty good.
Yeah, $50 an hour is an excellent wage. Yes.
When it's miles per
You could just do MPH.
Okay.
But you don't have anything for dollars per hour. You have to have the per here. Good question. Alright, why don't I give you guys just a second. I want to see if you can do the 1, 2, 3 steps for part B. Go ahead and try part B. What is my label that's going to be on the top?
Miles.
Not miles, because when you read it, it's miles on 8 gallons, so it's miles per. So I'm gonna write miles per gallon is GAL. Okay, you can put G because this is a common one that is just MPG. And when you see MPG, you see that on car commercials a lot. So then I put 220 miles per 8 gallons. Then how do I solve it?
Divide.
So 220 divided by 8. 8 doesn't go into 2, but it goes into 22 twice, which is 16. 22
7.
minus 16.
6.
6. Bring down the 0.
7.
7 times 8 is
56.
4 left. Add a decimal, bring it up.
0.
0, bring it down, and it goes into 40
5 times.
5 times. Then you're going to rewrite it as 27 and 5/10
MPG.
miles per gallon. So you can just do MPG, or I can say miles per gallon. Either way is fine. Alright, look at the top of your next page. Our next example says finding the unit price of the cost if it costs $2 for 8 juice boxes. What always goes on top when I'm talking money?
Dollars.
Dollars. Cost is always on top. So this would be cost per what? Box or juice box. It doesn't matter. I'm just gonna put $1 per box. Okay? So then we go into, it's $2 for how many boxes? 8. Now, when I divide by 8 to get this to equal 1, I can't really do my division very good there. So I'm just gonna do my $2 divided by 8. I just didn't have enough room here. So 8 doesn't go into 2, but bring up my decimal. It goes into 20 twice. 16 left. So 20 minus 16 is 4. Bring down the 0. 8 goes into 40 5 times. Instead of an X, I'm going to actually have to have a 0 because I need to have my dollar sign. So my final answer is 25 cents per box. So each juice box costs 25 cents. Now, we're getting to this point. If I show step 1, step 2, you're going to get to a point where you can just use a calculator to do the 2 divided by 8 and then put your step 3 on your paper. For right now, though, we are still showing work. Try C. Find the unit price of a 4-pack of mixed fruit if a 4-pack of mixed fruit sells for $2.12. What's the unit price if a 4-pack of mixed fruit sells for $2.12? It's a pack of fruit. So what's each item in there called? It's a piece of fruit. So it's so much per piece, so much per piece of fruit. Even if you use the general term item, I don't care. Because at the end you'll say it's so much each. So in all the things that we do, what goes on top?
The numbers.
The dollars, right? It's always cost per something, cost per something, cost per pound, cost per ounce, cost per item, cost per gallon. It doesn't matter. It's always cost first. So then I am going to start with my label, cost per, and this is the unit price of a pack of mixed fruit. So my item is down here. I can either call it fruit or item. It doesn't matter. But it's not the whole pack. Does that make sense?
Yeah.
Okay. So then I put in $2.12 for how many are in the pack?
4.
How many items? So 4 would be on the bottom. So then I take $2.12 divided by 4. 4 doesn't go into 2. 5 times.
3.
So it's 3 times. So I would say find the unit price. The unit price is 53 cents. And your label should actually be each. Cause or per piece of fruit.
I put.
It's not the pack. Okay, because the pack is $2.12.
I put /fruit.
Slash fruit, piece of fruit. Because if you're in the grocery store and let's say like here's your fruit or whatever, and it's on their shelf. Let's say these are oranges. They have a little tag here. It'll say the unit price down here, and the label for because they have to abbreviate a lot for each. It would say the 53 cents and then EA. EA stands for each. So each item.
Light bulbs just went off.
Ding, surprise.
That makes a lot.
Okay, let's go on. And now, here's where something comes up to where we were doing our notes the other day and labeling. I need you, before we even read through this, these are charts. These will go along with coordinate graphs. This would be my X or Y?
Y.
X,
Or yeah.
Y. So I need everybody to put a big X and the big Y. Then down here, we're going to say K equals, how do we find K? K is what? Y over X. And K is my constant. So then in order to have an equation with that, it would be Y equals K times X. Write all of that in there. Yes.
I'm still kind of confused what the K and all that.
K is once we find the unit rate, okay? If they all have the same unit rate, they have a constant, right? It all comes down to one number. Okay? If they're all constant, reducing down to the same number, they're considered proportional. So it's a lot of confusing things, which really, it's not as hard to do. All you have to do is do y divided by x, like what we have been doing. And whatever that equals, if it equals the same for all of these all have a constant, and they'd be considered proportional. That's gonna come later to another. I'm getting you prepared right now, honestly, for another lesson. I'm just kind of putting it in now.
Alright.
Does that make sense?
Yeah.
Okay. Kind of giving you some information. Hey, kind of look at this. I see it. Get used to just, what the big thing is, get used to y over x.
Alright.
Okay? Knowing that this is x and this is y. So it says the price of 3 different bags of dog food are given in the table. Which size bag has the lowest price per pound, rounded to the nearest cent? If we have price per pound, put a box around that. That's telling us what order we need to have it in. And no matter what, cost is always first. Price is always first. So I'm going to come over here and I'm going to put price per pound. I'm showing that I'm setting up my labels. Then I'm going to go over to my chart and I'm going to find that the 40-pound bag is $49. Does the 40-pound bag go on top?
No.
A lot of times people want to do it. That's exactly why I do this first. And not all do you guys want to do it. Sometimes I want to do it when I forget about it. I'm like 40 pounds for, because they might say you might get you might get 5 shirts for $25. It's not 5 divided by 25. It's really the dollars, 25 divided by 5. Okay, so the cost is $49. So I'm going to put $49 here. Divided by the pounds is 40. Then I'm going to show it's 49 divided by 40. Somebody get out the calculator and just do that for me, please. Because you guys are going to get your calculators as long as I show. Bam, bam, bam. Then give me your answer. Yes.
Is that Desmos thing on the Chromebook?
And you can get to it on a Chromebook. The Decimal Scientific Calculator, you just have to go to the online version, Safari, and type in Decimal Scientific Calculator. Yes. Okay.
Okay, 1.225.
Okay. So we can't have 1.225 as an amount, so we're going to underline the 2, arrow to the right. So it's $1.23 per pound. That would be the 40-pound bag. Then we go down, and you see how they just keep doing it for us, right? And we have these squiggly lines because they rounded everything. So if it's $1.23 per pound for the 40-pound bag, $1.17 per pound for the 20-pound bag, or $1.24 for the 8-pound bag, which pound bag is a better deal?
The middle.
The middle one, which is the 20-pound bag, correct?
Yes.
Because it's cheaper. Only a few cents, but it is still cheaper per pound. Go on down to the next chart.
Cheetos.
Tito wants to buy some peanut butter to donate to the local food pantry. Tito wants to buy as much peanut butter as possible. Which brand should he buy? This one is not really written like my X and my Y because it adds the brand name on the left. Right?
Yeah.
But this would still be my X and this is still my Y because my cost is always on top and Y is always on top. So if I wanted to figure out how much it costs for the nutty, I would put cost per ounce. And really, if you're doing it for a chart, if you at least just write it once, that's fine.
Okay.
So the cost would be, what is it, $2.19?
Yeah.
So I put $2.19 on top, divided by 12 ounces. Then I do $2.19 cents divided by 12 ounces, and what does that come out to be? You guys have a calculator? Because on your work tonight, you're gonna be using your calculator, but I show step 1, step 2, step 3, and what's the answer?
8.1825.
0.1825?
Yeah.
Okay, but we need to round it, so we're gonna underline the 8, arrow to the 2, so it'd be 0.18, so it's 18 cents per ounce. We're gonna keep doing that, so then we do to grandmas, we go $2.79 for 18 ounces. So do that in your calculator. $2.79 divided by 18. What do we get?
0.1.
Go ahead, Chance.
0.155.
Again, we can't go out to the thousands, so we underline the hundreds. Arrow to the right, and it would be 0.16. So it's 16 cents per ounce. So who is cheaper so far? Nutty or Grandma's?
Grandma.
Grandma's is cheaper. Let's go do the next one. $4.69 for 28 ounces. Again, when you're doing the work, you have to show me what you're putting in your calculator. So $4.69 divided by 28 is
0.1675.
0.1.
675.
I can be done with that, right?
Yeah.
Underline the 6, arrow to the right, so it's approximately 0.17. So 17 cents per ounce. So Grandma is still winning. Let's try Save a Lot. I always try to go to Save a Lot thinking I'm saving money. So I do $6.60 over 40 ounces. Please take $6.60. Gracie, you can tell me. 165. Ooh. Okay. There's a good reason why we kept our answer here. We have 0.167, 0.165. So I have to compare the 5 and the 7. 5 is smaller. So who is cheaper? Save a Lot. So that's why when you're doing it on your calculator and you are rounding it, you do need to go those next digits. So if it gets close like that, because that would have been rounded up to 0.17, well, that's the same as this. But they're really not the exact same. Go ahead.
Which one's better?
Save, no. Oh, I'm sorry. There's Grandma.
Yeah, that's what
I'm sorry. I got that messed up with this one here.
Yeah, you can point it at that one.
I'm sorry. I keep pointing to this one. I did that wrong. 0.167 this would have been 17. So I was comparing these two, but that's up to 17. But Grandma still won because she's 16 ounces.
Push
Good job, Grandma.
Okay. Turn the page. Look at the example 4. I believe it's example 4. It just says next example, and it is number 4. What I want you to do is I want you to read through that. This is going to be your homework. And then you're going to do numbers 1 through 3 in the guided practice. You can stop that.